Hello and welcome to another video about Unreal Engine 5. In this video we will make a vehicle. We'll set it up from the scratch and then we will make it follow a spline. Now when to start with you need of course to activate the Chaos Vehicle plugin. This one. I already activated it. When you activate it, it will request restart. You need to restart the engine, and now make a new blueprint. Vehicle. You choose wheeled vehicle pawn. Let's call it uh, Typhoon truck, because I will use the Typhoon skeletal mesh. No. And we need the vigilante content. I will use the Typhoon truck, this one. You can use any truck and any mesh, and there is some difference. If you use a vehicle with 4 wheels, it will be simpler, but if you use a vehicle with more than 4 wheels, there is some difference in making the vehicle. I will delete these blueprints. I do not need them. Now that we deleted these, we need to go to the physics assets. You can leave them like this. Need to delete the root. Select all bodies and make it simulate physics. Simulated. In the skeletal mesh, we need to make sure that the root, this one, the root bone, and the root and the cog bone is the x-axis is facing forward, and also we need to make sure the wheels also facing forward, the x-axis, because if they are not facing forward, it will make us some problems. Let me show you. If you choose this vehicle, the gas, sorry, where is it? This one, Tiger. This vehicle, the axis is wrong, so you need to take it to Blender or another 3D software to correct the axis. The right way should be the X forward. Now after we make sure of this, now let's choose the Typhoon. We need to create a blueprint, animation blueprint, and the animation blueprint in the where is the class settings? Class settings. We need to make sure to change this to vehicle anim instance, because you will not be able to make a wheel animation if you don't use the vehicle animation instance. Mesh space ref pose and wheel controller. Now after that we do not need to do anything in the animation blueprint, only we need to set up the wheel controller. Now in the blueprint we need the animation blueprint Typhoon. Let me add spring arm. make it 150 and 1500. Also add camera. Let's set up the camera rotation first. Let's make sure it uses the pawn control rotation. And we set up the control rotation. Turn and look up. The turn, we need to add control rotation U. Add control input U, and this one here we need to add controller pitch input. Now also I need to, this is for if you wanted to generate hit. I need it because my damage system depends on the hit result. Now to set let me just take it. Where is it? Now we need to create wheel blueprint, two wheel blueprint, one for the front, one for the rear. Chaos vehicle wheel. Or Typhoon front wheel. To duplicate it. Rear wheel. Now we open the front wheel. The radius we will change it. Let me make it 60. And we also need to change the front wheel. We do not to be affected by handbrake. We need to make it affected by engine and by a brake. Also front wheel affected by steering. Leave it 50. And we may need to change the roll bar scaling, but we will test first. Test the vehicle and then change these settings. Also make this 60. Want it to be affected by handbrake and by engine. I think this is enough. Now let's go back to the vehicle. Here, if as I said, if you use a vehicle with 4 wheels only, you can use this default vehicle movement component. But if you are like using like this with 6 wheels or more, even tanks, you need to use the chaos wheeled vehicle movement. In next video I will set up a tracked vehicle in next videos after we finish this the videos about the wheeled vehicles. Now move forward. Let's set up the moving forward and also the moving backward. Set throttle input. The difference here is not like Unreal Engine 4. Here you need to set the brake input different with different node than the input. Brake input set brake input. Set not get. Set brake input. In Unreal Engine 5, the input throttle input controlled both the brake and throttle. Now we need to multiply the value by -1, because when you are pressing forward, the value will be 1. Here will give you positive throttle and negative brake. But when you press the back button, this will be negative and will be giving no throttle, and this will have positive and will give you brake. Also move right, steering input. Now we need to set the wheels. Now let's go. We need 6 wheels. 3, 4, 5, 6. Let's go to the skeletal mesh and copy the wheel name. This one, the front left. Make sure to put the front wheels in the first index. Like if you have 2 wheels in the 0 and 1. If you have 4 wheels for the front, like in a BTR or another vehicle, the first 4 wheels should be the front wheels. We choose the Typhoon front wheel and paste it here. Also this Typhoon front wheel, this one, this is the rear wheel, Typhoon rear wheel, also Typhoon rear wheel, this one rear wheel, and this one, the last one, also rear wheel. Let's set up the left. Start with this one here, left, change this one to 3, and the right, this one, right, and this one, change the number to 3. You need the name to be exact to be able to work. If any error in the spelling or different letters will give you problems. Now let's test the vehicle. First I will set it correctly, then we will make it follow a spline. Oh, sorry. Let me delete this one. Delete. Now let's test. Doesn't move forward or backward. We forgot to set the engine curve, the torque curve. Where is it? engine setup. Let's increase the torque to 1000. Make a simple curve. Differential, let's make it all-wheel drive. Let's test it now. No, it's going forward. It's doing a wheelie. We need either decrease the torque or increase the weight. I will increase the weight of the vehicle. Make it 5 tons, 5000. Now you see it flips very easily. Now you need to change some values in the wheels. The front wheel. Let's go to the roll bar scaling. Increase it to 0.5. Also go to the rear wheel roll bar scaling to 0.5. And now let's test it. No, it doesn't flip easily. I think we need to increase it more. Let's make it 0.75. And here 0.75. Still, let's increase it to 1. Rear wheel 1. Well, it is very tall vehicle, so it flips very easily. We need to change the spring rate. Let us increase it for the front and the rear. You need to, what I did is increase the weight and decrease the torque to make it stable, but still it's unstable. It can flip very easily because it's tall vehicle. Now that we set up the vehicle, we need to make it follow a spline. Now let's make a spline. no, let's make an actor, call it BP road, or path here, spline. No, we don't need anything from it. Uh, you press Alt and drag to make more points. Let's make line that turns around and getting back to the same point. Now, in the typhoon, begin play. Get all actors of or get actor of class. Pass. Let's call it pass. Now after we got the spline reference, we need to calculate the path. Now let's make a new function, call it find path. We need an input, call it path. The input should be the path blueprint we made, blueprint path, object reference. Now get spline, get spline. Now we need to find the closest tangent, find tangent closest to world location. Change the coordinate to world, and the world location is the actor location. Get the actor location. Now we need to normalize the vector and multiply it by this value is the distance that the vehicle will see the spline point. If you make it very large number, the vehicle will sense the spline point from far and will adjust the wheels early. If you make a small number, it will adjust it late. So you need to find the best number for you. For me, 1000 is good. Now you need to add the vector to the actor location. When you add two vectors, the vector that will the new vector will be relative to the main vector. I mean this location, the closest tangent will be always relative to the actor location. so it will change with the location of the actor. And now we need find location closest toward location. This location will be, we will find it is the closest to the location that we made. Now we need to look at rotation. The start point will be the actor location, and the target will be the location we found the coordinate for. Get actor location. Delta rotator. Always put the actor location in the A. Get actor rotation. To break the vector, the rotator I mean. Clamp, map range clamp, sorry. Now, if the value is 45 and more, we needed to give us -1, and if it was -45 the rotation, we needed to give us the 1, and these will be the input values that we will use in the steering. Return node. Now called steering input. Let me delete this because I was testing. Now I think we are finished. Let's take the tick and our find path. The path is the one that we set in the beginning play. We need the steering input. Take it here. And let me break this. And on begin play I will set the throttle input to 0.5. Now let's test. Sorry, I forgot to set it to 0.5. I will set the throttle first to 1, then after 3 seconds I will set it to 0.5 because it will become too fast and will flip the vehicle. It's easily flipped. Now let's test. Now let's look at it. It's moving. It's turning. It's turning now. If it is moving slow, it will be accurate. In the next video, I will make the vehicle adjust when it enters a corner. If it's sharp corner, it will uh, press brakes before entering the corner, and after exiting the corner, it will press throttle and will adjust the speed according to the corners and the road conditions. This is the end of the supply. Now we finished the concept is now, I think it's good, but we need some adjustment. Like I said, I will make the vehicle adjust its speed according to the corners and the road conditions. Thank you for watching, and see you next time.